Ladies and gentlemen, we now move into the core segment of today's technical forum. This evening, we are privileged to hear from an exceptional lineup of industry experts and professionals representing globally recognized technology providers and leading institutions in Sri Lanka. They will be sharing valuable technical insights, practical experiences, and emerging industry perspectives related to rooftop solar systems and battery energy storage safety. Following the presentations, we will have a dedicated Q&A and interactive session to give our audience an opportunity to engage directly with our speakers and stand a chance to win exciting gifts. With that, I would now like to invite our distinguished speakers to kindly come forward and take their seats on the stage. I first invite Engineer Amila C. Rajapaksha, Director, Environment, Efficiency and Renewable Energy at the Public Utilities Commission of Sri Lanka. Next, Engineer Aaron Lee, Solution Manager representing SunGrow. Next, we have Engineer Charit Shainakar, Chief Engineer, Ratmalan Area Electricity Distribution Private Limited. Joining us online this evening, we are also honored to have Engineer Mo Haike, Senior Solution Manager representing Huawei. Thank you all. Without further ado, we will now proceed with the first presentation of the session. With over 15 years of professional experience in the electricity sector, our first speaker has been actively engaged in electricity sector regulation with a strong focus on licensing functions and licensing condition monitoring. He is an engineer by profession, holding a BSc Honors degree in Electrical and Electronics Engineering from the University of Peradeniya, an MSc in Electrical Installation from the University of Moratuwa, and an MBA from the University of Colombo. He is a chartered electrical engineer of the Institution of Engineers, Sri Lanka, a member of IEEE, and an associate member of the Sri Lanka Energy Managers Association, reflecting his strong professional standing across both engineering and management domains. Please join me in welcoming our first speaker for the day, Engineer Amila C. Rajapaksha, to the stage.
Thank you, and very good evening for all you. Safety of the rooftop solar system as well as the battery energy storage system. So let's talk about, I think you all aware and know about the technical items and marketing items, as well as other aspects. But when it comes to the safety, I think this is the first time we are going to talk about how the regulatory aspects would be, the way of thinking of the regulator. What is the power vested with the energy regulator when it comes to the electrical safety? Right now, at the moment, the electricity sector of the country is governed by the Electricity Act, that is 2024 Electricity Act, and recently we had amendment of 2025. In the Electricity Act, they have identified PUCSL as the sector regulator. And on the other hand, it says the Ministry of Energy as the policy maker need to come up with the tariff policy as well as the electricity policy. So the implementation of the Electricity Act, the provision of the Electricity Act, as well as the provision of the elements of the policy has to be done by the mainly by the regulator with the support of the NSO. So how the regulator is going to implement the provision of the Act, provision of these policies? By issuing rules, regulation, codes, guidelines, and see the compliance monitoring and enforcement, licensing. So those are the aspects of the regulator when it comes to implementing the provision available in the Act and the policy elements. So what are the provisions available in the Act when it comes to the safety? So I told you, Electricity Act is a governing document in our country as per the law. Specifically mentioned when it comes to electricity safety, all the electricity sector supply chain activity, that means generation, transmission, distribution, supply, usage, procurement, storage. So every activities should be safe for the general public. There should not be any risk for the public. So Act says it should be safe. Electrical industry should be ensured by the regulator, mainly when it comes to the activity. In addition to that, in the PUCSL Act, where the PUCSL has been established, it also has given powers to PUCSL to promote the safety and ensure the safety. For that, PUCSL Act empowered PUCSL to come up with the necessary regulation, rules, codes, and guidelines and standards. So that's how PUCSL ensure the electricity industry activities are executed in a very safe manner. In addition to that, in the draft electricity policy, which was finalized very recently and about to be published, it says to ensure the safety, the electricity supply chain equipment should be standard. So that's clear. In the policies, in the regulations, in the law, the safety has been clearly identified when it comes to the electricity sector supply chain activities. So law is there. Now, ultimately, who is responsible for ensuring this safety? That is all the entities, parties, individuals who are engaged with these activities, as well as the utilities, it has a collective responsibility to ensure the safety. But in overall, PUCSL has the vested mandate to overall ensure the safety. So now I hope you all have the clear picture how safety has to be ensured as when you come to the regulator's point of view. So today's topic. Now, regulator has the power vested down from the Electricity Act, from the PUCSL Act, and the policies to ensure the safety. When it comes to the rooftop solar and batteries, why is the safety matter? Now, right now, I think 2.2 gigawatt, more than that, rooftop solar, some of with batteries are available in the distribution network right now. Our total installed capacity is around 6 gigawatt. So 1/3 of installed capacity in our country are in the LV network, where behind the meter, at our premises, our houses, industries, hotels, and there would be new tariff. Under the new act, the regulator is empowered to publish the feed-in tariffs. So very soon, mostly by end of June, July, we are going to publish a tariff, feed-in tariff for the battery and solar storage system, where we have requested national transmission operator and the distribution licensee to allocate around 100 to 200 megawatt of storages in the system. So there would be many more stored energy storages as well as the solar system coming into the market. But the issue is all are behind the meter, and the people don't have much awareness, technical expertise to handle this stuff. So that's where the safety has to play a much bigger role, where PUCSL as the regulator as well and the other entities, including the distribution licensees and the NSO and other entities, have to ensure those installations, those equipment are safe. So how the PUCSL is going to ensure this one? I hope we have seen this news recently. More than 60% of home battery installation inspected in Australia are substandard. That is in Australia, a well-matured market. Then what about Sri Lanka? These are some images we took with our inspection programs, where PSSL visiting some, these are the basically related to the rooftop solar inverters and their system burns. Damages taken place, and some malpractices, non-standard installation practices. So that's how the installation practices in Sri Lanka. So if you take just a solar PV system, these are the standards list of items. And these are the possible risk areas where we have to consider about the safety. So I told now, PUCSL has the overall authority to ensure safety, but how? We have, these are the regulated tools we use to ensure the safety. Those are license and exemption. That means to generate electricity, to transmit electricity, to procure electricity, distribute, supply, store. For every activity, a person needs a license or an exemption. In the license and the exemption, we have specifically mentioned clauses that responsible party have to ensure the safety. And some data requirement, some development code of practices like that. In addition to that, we have a regulation called Electricity Safety Quality Continuity Regulation, which was published in 2016, which specifically mention about the network side as well as the installation side. Safety aspect has to be met. And the license application regulations. So another regulation in which any person who are submitting application to get a license from the PUC have to declare their safety statement, their safety manuals. In addition to that, we have distribution code developed by the distribution licensee, that is previously CEB, now the EDL and the LECO, where we have some provision with respect to the safety when it comes to the rooftop solar and the storages. In addition to that, we have issued 3 guidelines when it comes to the off-grid solar, grid-connected solar for utilities as well as the solar system service providers. So we have some tools, nice tools we have. So how we are going to implement this, ensure the safety? That is always our regulatory tools, always linked with the standards. Simply, we have to ensure whatever the equipment coming in Sri Lanka, maybe inverters, maybe storages, maybe panels, cables, should be in line with the local or international standard. Once the standard product comes to market, the installation should be done by the properly accredited people. And then commissioning, and hereinafter O&M. So always we are trying to adapt with the standards. So now at the moment for the rooftop solar system, especially for panels and the inverters. SLSI has come up with their standard. They have published a code of practice as well. From the Sri Lanka Sustainable Energy Authority, they are restricting the coming non-standard product to Sri Lanka through the customs. That mechanism has already been established. In addition to that, under the Sustainable Energy Authority, they have a mandatory registration for all the solar service providers. They're also there. So products, equipments are now standardized. The installation companies are registered. They have a guideline for the installation. And next, the commissioning. A chartered engineer is required for commissioning report before give the connection for the CEB. More than that, from the PUCSL side, recently we granted our approval to install more than 600 megawatt of battery storages for Sri Lankan grid. Approval was granted, and the national system operators progressively starting their procurement to procure these storages for their utility networks for the grid substation. In addition to that, we have granted 100 megawatt of battery storages to add into the LV network, that means behind the meter. So batteries would be the future. So there should be a policy in Sri Lanka with respect to the energy storages. Now the policy is underway with the Sri Lanka Sustainable Energy Authority. Also recently we gave a directive for Sri Lanka Sustainable Energy Authority to consider storages as well as the off-grid inverters for their equipment list. So then with the agreement they're having with the customs, non-standard products are not coming to Sri Lanka. At the moment, only grid-connected inverters are filtered through this process. So we gave a directive for them and they agreed to work with these storages as well as the off-grid inverters to be considered. And the standard for batteries, we have worked with the SLSI. They already prepared, they are going to publish the SLSI, that means adopted standard. And in addition to that, they are going to prepare a code of practice for battery storage as well. All are in progress at the moment. In addition to that, what we feel, if you take the inverters, all are coming under one HS code. So how we can link, because when it comes to the inverters, there are off-grid inverters, hybrid inverters, various kind of inverters at the various standards to be met. How we can link particular type of inverters with the particular type of standards. For that, we are working with the customs to subcategorize the existing HS coding system. If we take inverters, now we have one HS code. So we are trying to segregate different HS code for different equipment. So then we can link the SLSI standard with particular product. Then we can, through the import and export control, we can ban the all substandard product, non-standard product coming into Sri Lanka. So we are working on that. But still, we are getting a lot of complaints regarding the service of the solar service provider in our country. That's why Sri Lanka Sustainable Energy Authority has taken a step to introduce a kind of a grading mechanism for those institutions, because ultimately they are the institutions who are going to install the rooftop solar and batteries in Sri Lanka. So there should be a good standard practices they have to follow. So there are some training programs, but ultimately there should be a mechanism to ensure those installations are in safe manner up to the standards. Further, PUCSL and SLSC are conducting kind of training programs. In this training program, safety is a critical chapter. And with the support of UNIDO, a funding agency, we are giving standard equipments demonstration board for the technical colleges in order to uplift their educational level. So what we are expecting at the end of the day, the market, the set of electricians are coming with the required qualified skills and knowledge. There are malpractices, many. So you all know about that. Once the installation is done, some people are tend to change the panels. add the panel, change the inverter, adding batteries, without informing the distribution licensee, EDL or LECO. These are not the standard practices. In addition to that, we had a public consultation to identify what are the existing issues in the solar industry. So sad to say, we received some representation with respect to the signature of the chartered engineer, because it's a must for CEB or LECO, EDL or LECO to give their connection. So we officially wrote to IESL, there's something we had to look at about your membership. So we are working with the IESL we have a system, but we have to ensure the system is work properly. If not, ultimately, as chartered engineers, we have some ethics. We should not put our installation into an unsafe situation. In addition to that, there are some O&M negligence, poor working workmanship, and unsafe firing regulations. There are many malpractices. So as a regulator, now we have tools, standards, procedures, everything. So how we are going to monitor them? What is the practical way? That is, in the act again, it's have established electrical inspectors. That means PUCSL has electrical inspectors. They can appoint electrical inspectors to go inspect and see is there any violation of the rules, regulation code prepared by the PUCSL. So that provision is there. Right now, we have some inspectors in the PUCSL. They are doing their job. They are selecting some sample, rooftop solar. They are visiting those places, inspecting those places. And then, what are the commission action when it comes to the violation? Right now, monthly, we are getting information from Sri Lanka police on the number of electrocution happening in Sri Lanka monthly. But I'm happy to say there's no statistic regarding the electrocution taken place because of the roof of solar system or the batteries. But we don't know about the near misses. No information on that. So under the acts and the rules, we have some provision called enforcement orders, where if somebody is violating, maybe a person, maybe an organization, somebody is violating any provision of the act, maybe a safety provision, we can go for a general penalty as well as the enforcement orders. So as a regulator, there are many more things we have to do. I told now, after another 2-3 months later, there would be a feed-in tariff for the battery and solar system. So we need a standard and procedure for grid-connected BESS installation. So we have to work with the distribution licensees. Very soon we are going to start conversation with them. And preventing the use of non-standard BESS products. Right at the moment, we don't have a proper procedure to import BESS or the batteries only for the solar projects when we come to the small scale projects. So in the market, there are many batteries available. People are using those batteries for the solar installations. So we had to think about how we can prevent that scenario. When it comes to the grid connection, definitely the distribution licensee engage with the prosumer or the customer, where they can see the installation is up to the standard or not. But when it comes to the off-grid solar, we don't have a proper mechanism to ensure that off-grid installation have been done as per the standards or for the required regulation. So that again another issue, because we have issued a guideline. Yes, for the off-grid we have issued a guideline, but we need a mechanism to develop the off-grid installation has been done as per that guideline. That we need to develop immediately. And if you take any other country, any electrical installation as well as modification, to do that, they need the accredited electrician or the licensed electrician. But in our country, it's not the practice. So immediately we need to bring this kind of a mechanism, any installation, the modification should be done by an accredited electrician. So we already discussed with the distribution licensees. They agreed for their supply sources code to add this accredited electrician. So then we can ensure the installation is done by accredited electrician and there is a responsible person for that installation. In addition to that, we need to improve the awareness level of the general consumer on electrical safety and these battery systems, how to maintain them, and strengthening the consumer protection, that there are rights and obligation, what consumer can do, what cannot do, and there should be a kind of a mechanism for robust enforcement, continuous compliance monitoring, and strict action against the violation. Further, next issue is going to be a second life of batteries. Once the battery lifetime is over, what we can do? Is there any mechanism in the country for disposal or re-export? Under the Central Environment Authority regulation, there should be a licensed person to collect these disposal mechanism items and re-export or do whatever the disposal work. But there are some trends in Sri Lanka to use these batteries as secondary applications, especially V batteries used for the solar. So there should be a mechanism what we can do with their second life. So those are the future challenges for regulator has to think when it comes to the safety of the electrical installation, solar installation, and the battery. So finally, the future of energy must be both clean and safe. Thank you.
Thank you, Engineer Amila. This evening, we are pleased to have SunGrow as one of our valued partners joining us for this event. SunGrow is dedicated to advancing renewable energy solutions with a strong focus on innovative and efficient solar technologies that support sustainable energy development. Their commitment to quality and performance continues to contribute significantly to the growth of the clean energy sector. We now invite you to take a moment to watch this short video that highlights their journey, capabilities, and impact in the renewable energy sector. Let us now move on to our next speaker for the session. With a Master of Engineering in Electronic Information Engineering from Sidian University, he brings a strong academic foundation in advanced electronic systems and renewable energy integration. He has accumulated 3 years of international field experience and has been actively involved in the technical implementation of commercial and industrial photovoltaic systems and residential solar solutions. He has previously served in South Africa, where he led and supported project execution and on-site technical delivery for distributed solar applications. With that, I would now like to invite Engineer Aaron Lee to the stage.
Sorry, so you have for me to focus on the maybe I need to. From the beginning to the thank you. Because I don't see the screen. Sorry for the delay. Good evening, everyone. This is Aaron Lee. I am from Sungrow Distribution Business Center as a pre-sale solution engineer. And I would like to express my admiration for today's event and for your community. It's such an honor to be here today. I feel like it's not just another presentation for me. It's a dialogue with the intellectual backbone from Sri Lanka. And I do believe it's a shifting phase from the shifting phase to a long-term reliability. And in our industry, we always talk about the megawatt, the efficiency. But to be honest, as an engineer, I do believe the benchmark supposed to be resilience always. So Sungrow has deployed over 660 gigawatt PV inverter across the world. Just last 1 year, we have finished 143 gigawatt PV inverter. So this kind of number is not just a record. It's a massive database across the real world. So I do believe that we need to work together, both Sungrow and Sri Lanka, for a more sustainable country. Because Sri Lanka is it's a really nice country. I love here so much. And today my presentation is going to be focused on the DC side risks. So I will, it's going to be divided into 3 parts. And part 1, we're going to focus on the AFCI, so kind of knowledge to stop the arcade fault. And part 2, we're going to focus on the rapid shutdown. And part 3, I will make a summary about the DC side risks protection. And if there are any problem, you can stop me. Yeah, so we're going to start with the part 1. Okay, so the full name of FCI is called arcade fault circuit interrupter. So actually, when a circuit is damaged, so the current will literally break through the iron and intense the flow of energy. So this process will generate massive heat. So that will be the spark leads to the fire. Actually, DC arc are the main reasons of PV fires. So with thousands of connection points in a largest CNI PV plant, so if there was no advanced technologies, it's impossible to stop the DC arc fault. So where the risk is clear, but how to identify a real arc rather than a fake news? That's the point. I make a list here. You can find that from this slide. There are many 3 challenges of the arcade fault identification. First one is the weak signal versus the heavy noise, because the arcade fault signal is really tiny. It's easily to be buried by the noise. The second is the variable characteristic, because for the arcade fault, there was no standard image. It always changed. And third one may be the most challenging, because currently the PV plant is larger than ever before. So as I said, there are more than thousands of connection points, makes it a huge challenge. And the equipment is also aging. So how to make a long-time constant detection? That's a huge challenge. So I want to show something about Sungrow here. When we talk about AFCI, we are not just talk about a lab prototype. We have been dedicated to the AFCI function for 15 years. Actually, we are among the first company in this industry to acquire the certifications like the UL 16999B from the North America, and the IEC 63027 is from the International Solar Photovoltaic Energy System. So when we talk about AFCI, so we are talking about a field expert built on 15 years of experience. Okay, here's the new release, the AFCI 3+ from Sungrow. As you can find from this slide, we have pushed the safety boundary to a new level. It now supports up to 40 ampere max current per MPPT and 600 meters cable length. So making it a perfect choice for the largest CNI system. And also for the sites maybe where the grid connection point is close to the inverter, but the PV panels are located far away on distance rooftops or some remote ground areas. So that's the point. And Okay, so how to understand those two parameters? I make a slide here to show you. Actually, the 600 meters is from the positive terminals of the inverter. Let me use a pen. Yeah, it's from the positive terminals of the inverter and it goes to the farthest PV panels and then go back to the positive terminals. So this loop, no more than 600 meters, AFCL will have a reliable performance. And for the 40 ampere, let me take an example from these products. We do have 10 MPPT, and each MPPT will have two strings, the string A and string B, and it will combine into one after entering the inverter. So each string could support 20 ampere. So that's the parameters introduction. And also I want to show you where this capability comes from. So I'm going to introduce from both hardware perspective and software side. So from the hardware side, I think there are many three points supposed to be noted. First is a high resolution sensor. You can think it is a earphone and it's at the very beginning of the circuit to capture the most subtle arc signals. And the second one is a new analog filter. I'm not sure have you someone experienced the new AirPods Pro with the noise cancellation? So the new analog filter is kind of noise cancellation to filter the noise to make the system hear the arc fault more clearly. And third one is available computing capacity. And as you can find here, we push 100% more results on the AFCI. So which is allowing system to analyze the more complex arc fault. So that's the hardware upgrade. And last slide is about the software. So how we do the identification for the arc fault. That's the key point. The core logic is the left part of this slide, the 3-level detection and 2-level closed loop logic. And I'm gonna use the right corner diagram to show you how does this 3-level detection works. This one is the CT, the current transformer, was used to catch the arc fault signals. And the arc board, actually internally we call it arc board. So it is a arc detection unit. It's a separate board was put on the motherboard of the inverter. So for the arc board, it will do the analysis or the match. And then it's a DSP. DSP is the brain of the board. IGBT is the core components of the inverter. So how does the 3-level detection works? Like this, the CT capture the signals, the arc fault signals, and then forward to the arc board. And on the arc board, we do have a local database on the flash, data flash. So the CT forward the signals to the arc board to match, no matter the results. And then we go to the level two, because sometimes the inverter will make its own noise. So level 2 will make the decision whether this noise comes from internally or it's a truly arc fault. So if there still cannot make sure from the level 2, and then we go to level 3, the IGBT will do a suicide trial to cut off the current instantly. And then if the arc board comes again, and that's a real arc. So if it just dies, because if you cut the current, the intensive flow of energy it just stopped. So it just dies like this. So that's a 3-level detection. And for the 2-level closed loop, it's basically remember what happened, and you don't have to guess next time. Like the level 1 closed loop, if the DSP find there was a fake news, I will put it on the whitelist. Okay, it's a fake news. I will not charge next time. And if it is a real arc fault, it will be put on the database again. So actually, theoretically, with the time you use our system, the database will be much more stronger than ever before. So we use this kind of detection logic to make the system more reliable. So that's what we do from the algorithm side. And the right corner here is the trips logic. We set a trip logic for the inverter. If one day there are less than 5 times real arc happened. So the inverter will shut down for 10 minutes and it will automatically restart. And if the real arc would be detected more than 5 times, the inverter will shut down for the whole day and must be fixed by the human and then a manual restart. So that's the trip logic. Okay, so I make a summary here. FCI 3+ from the challenges to the solutions. So as I said before, there are the weak signals versus the heavy noise, and the variable characteristics, and the systematic complexity. So from some group solution, we do have the new hardware upgrade, like the high resolution CT and the new analog filter. And besides, the 3-level detection logic makes a reliable products. I want to emphasize here is that dynamic algorithm adjustment calls for the 3-level detection. We also introduce the deep learning method. So basically, every plant will have its own characteristics. So the algorithm will adjust the threshold of the arcade fault to make it more accurate. So that's a dynamic algorithm adjustment. So that's the last area is a highlight. As I said, the high resolution CT and the new analog filter will introduce more than 83% background noise suppression. It makes the system hear the noise clearly, and hear the arcade fault clearly. I'm sorry. And the second is the empowerability, like 40 ampere and 600 meters. It's a really good choice for largest SNI PV plant. And for the last one, we can detection and extinguish within 2 seconds. So here's about the AFCI. And because AFCI provides the intelligence to identify the threat, but the RSD, the rapid shutdown, will delivers the physical action to eliminate it. So as you can find from this slide, the images shows what happens when we lose control of the DC energy on a rooftop. So we know that as long as the sun is shining, those modules are active. So without a way to shut them down at the source, a small fault can quickly turn into a disaster, especially for the firefighters. So it's exactly because of these risks, and the global regulators to the international benchmarks such as America NEC 2020 and Thailand TCSEC 2022, so makes the rapid shutdown a necessity for the market entering standard. So as you can find from this table, basically they are the same to shut down the source of high voltage into at least 80 watt within 30 seconds. But as an engineer, we know that the real technical submit is maintaining 0 fault operation. So for some rule solution, actually we can decrease the source of high volt to 1 volt within 20 seconds, where much shorter than the regulation. So for this slide, I want to show you how that rapid shutdown actually works. We use a technology called PLC. As you can find from this diagram, the green line is a normal running. So basically, this Q1 is always closed. Q3 is open, and when okay, let me back to the PLC. The PLC is called power line communication. You can think it as a heartbeat signal. So people dies when the heartbeat stop, right? So it's the arc. So basically the point is how to control the control signals. So the inverter or the central controller sends the high frequency signal through the existing DC cables. So as long as the rapid shutdown feels its heartbeat, the system keeps running. But here is the beauty of the safety logic. The moment the signals disappear, and whether because someone pushed the emergency button or the AC grid failed, or even the cable was cut by the fire, the rapid shutdown units will perform a fire to safe shutdown instantly. So the real engineering achievement here as we discussed, is our dual modulation circuit. It's designed to filter out the heavy noise of a southern system to ensure that the heartbeats never lost. So this is how how our rapid shutdown works. Okay, let me repeat again. So the green line, the green line is a normal running. So whenever the signal of the heartbeat is lost, it will change to the bypass running. So the Q1 will open immediately. So the Q3 will close immediately. And the rapid shutdown will cut the PV panels from the system. That's why the high voltage will decrease in such a low level. And here's the system structure of Sungrow solution. Let me introduce from the left. Here's the PV panels, and we install this is the rapid shutdown unit. So it's connected to the inverter, and inverter do the parallel connection. So we provide a separate emergency button for the owner to use. Like sometimes you want to do the maintenance or some emergency situations. The firefighters will put the emergency button to cut the volt. And here is the communication devices that was used to upload the generation data to the IESL cloud. IESL cloud is a cloud platform, and we provide the open API for the users. And that's back to the rapid shutdown. There are two challenges we are facing right now from the industry. One is signal loss over distance, because to tackle this signal loss, our rapid shutdown is equipped with high sensitive dual modulation circuit. So even when the signal travels 300 meters and becomes extremely faint, the circuit can act as a dialogue ear to filter out the noise and amplify the heartbeat signal, so ensuring a stable connection. And another one is a PLC crosstalk. So to tackle the crosstalk, we use as you can find here, we use the unique on-code heartbeat and the multi-frequency PLC technology. This one is easy to understand. We put more bandwidth on the communication, make it more reliable. And for this one, I would like to give you an example, the unique on-code heartbeat. So when you do the installation, you put a lot of the DC cables into a tray. So inevitably, the string A's heartbeat signals will be influenced by the string B. So we equipped that, we programmed the string heartbeat signals with a unique ID, like string A with his ID and string B with his ID. So string A cannot understand string B. So even there was a PLC crosstalk, they cannot understand each other. I would like to give you a microphone, like soldiers cannot tell you the correct secret code, then he is a spy. So that's the same, similar to this crosstalk. So another thing about the PLC crosstalk is uncompatible. So it's better to use the one brand solution. If you choose Sungrow solution, it's better. If you choose Sungrow's inverter, it's better to use Sungrow's rapid shutdown. So if you choose another brand, you better choose their rapid shutdown, because they will make the system more reliable. Because as I said here, the rapid shutdown is not compatible. They do have their own unique ID or their own multi-frequency PLC technology. It's different. So that's why the different brand inverters and different brand rapid shutdown cannot understand each other. Okay, here's a dual and active safety. So for this slide, I want to emphasize from Sungrow, our FCI or rapid shutdown is much more advanced than the regulations. As you can find in the left corner, from the NEC, it allowed less than 2.5 seconds to detect RK fault and stop that. But from Sungrow FCI 3+, the farthest we can done within 200 milliseconds. And for the cable length, as I said before, we can do 600 meters cable loop. That means 300 meters cable length. And for the max current, we can support 40 ampere right now. So that's the advanced technology for the FCI. And for the rapid shutdown, we do support less than 20 seconds to download the high voltage to 1 volt. And for the rapid shutdown, we also provide the AFCI trigger. So that's what I said. to use one brand solution makes it more reliable. So we can use the AFCI to trigger rapid shutdown to cut the high voltage. So that's the system system advantage. Okay, part 3 is about DC side protection. I do have a summary for the DC side, what we can do. Here is an example from South Korea. It's a really good reference for Sri Lanka because you know there was a unmanaged variable in the large scale projects is an engineering challenge. So you know the installation, even though every brand was emphasize their after sales team, but the installation quality is unavoidable. There will be a risk, I'm saying, like the poor creeping of the connector. So you see this picture, actually it's because of the poor connection. It's melt because of the heat temperature. So from the South Korea, they do have regulations to install a separate fuse, like this picture, on the connector. So makes it separate or makes it an actual method to stop the hardware damage. So I think it's a good reference for Sri Lanka to, yeah. So the last slide is about the DC side protection summary. Actually, from Sangru, we do have different phase from the pre-start to the running stage to the emergency stage, even the shutdown stage. Okay, no worries about this too. So let me introduce one by one. From the module level installation positioning, it's well known as the IESL check. At the very beginning of the starter age of the inverter, the inverter has not get connected to the grid. So the system will detect the insulation between the PV terminals and the ground, and it prevents the current leakage and fire risks caused by the damaged cable or some poor connection. And second one is the PV negative grounding protection. So when the running stage of the inverter, there will be continuous monitor of the DC loop for the ground fault. So it will address the cable wear and tear leakage. And last one is a string level intelligence shutdown. It will use for some emergency stage. Let me give you an example with the new release products, SG125CXP3, we just released earlier this year. It has 10 MPPT separately, and we do have equipped with 2 separate intelligence switch, and every 5 MPPT will be connected to the switch. And if somewhere some string level MPPT is wrong or something emergency happened, another 5 strings will work normally. So that's the string level intelligent shutdown. At the same time, the app will also feedback you a percentage and a code. You're gonna have the percentage to calculate which levels, which PV panels have the highest risk. So you can do the maintenance more efficient. So that's string level intelligent shutdown. So basically, that's all from my side. As for the DC side rooftop protection method. So finally, I want to say we are looking forward to seeing you, all of you get some inspiration from the international benchmarks. And we wish to further strengthen the local regulations and market entry standards, because this is not, it's not about regulation. It's about ensuring a long-term healthy growth of Sri Lanka's renewable energy. And that's all from my side. Thank you so much.
Thank you, Engineer Aaron. As our next sponsor for this evening, we are pleased to have Huawei as one of our valued partners joining this event. Huawei is a global technology leader recognized for its continuous innovation in information and communication technology, as well as advanced energy solutions. With a strong commitment to intelligent and sustainable development, Huawei continues to play a key role in enabling smart and efficient energy systems worldwide. We now invite you to view a short video that reflects their presence and contributions in this field. As an alumnus of North China Electric Power University, his experience spans across multiple international energy storage projects where he has been involved in the development and implementation of large-scale energy solutions across several countries, including Sri Lanka, Maldives, and China. His work spans key areas within the renewable energy sector, covering both grid-connected and standalone systems, along with contributions to system integration and commissioning activities. He is currently engaged in a major energy storage project and has been with Huawei since 2022. contributing to a range of important initiatives across the region. With that, it is my pleasure to invite Engineer Mo Haike from Huawei to take the stage.
Okay, good evening, everyone. Could you see my screen? Okay, good evening, everyone. Very unluckily, I cannot join this meeting. I really hope to have some face-to-face discussion with you. So actually, my today's topic is regarding about the safety for the inverter and the energy storage also, because we know during we can see in next 1 or 2 years, even 5 years, the battery and solar will be the key trend for the Sri Lanka market. And also, thank you for the Aaron Lee. Already have a very good presentation about the inverter DC safety. So in my topic, so I will be reduce the DC safety part for the inverter. So I will be mainly to discussing more about the battery DC safety. This is safety. At the beginning, I will be still want to have some add more small information regarding about the DC arc regarding the inverter side. So Aaron Lee also mentioned for the DC side fault actually have different type of fault. So like the string current backfeed due to the string length difference, because if within one MPPT, each string have a maybe have a big differential with the quantity of the PV panel, the current will be different. Then it will be have some backfeed about the backfeed current to damage no matter is the inverter or the optimizer if you have this. And second is some risk for the electric shock for the maintenance guy, no matter is during doing the maintenance or doing the installation. And it is hard for the fire extinguish due to the high voltage of module also. In some of the Australian supermarket, you already have this kind of issue. Even the fire is happened, but because the PV panel is there, it cannot be shut down the voltage, so they cannot doing the fire extinguish work. And first time is the installation impedance is reduced. This one is normally happen, especially in some rural area. It will be caused by the bird or some metal was damaged the cable. It will be have some DC side ground to the short. Could you hear my voice?
Engineer Mo, would it that be possible to share the screen in a full presentation mode?
Sorry, is not full sharing?
Yeah, but could you please
Let
post
me
it in
reshare,
a full
let me reshare.
presentation mode, maybe in a PDF view? No, presenter view.
Let
what
me
is
stop
icon?
sharing, resharing, okay. Could
Yeah,
you see the screen?
great. Thank you, Engineer Mo.
Okay. Oh, sorry, I didn't aware of this. So the first type of the DC4 is reducing the insulation impedance. And first that is about arcing. I think the arcing is the main topic we're gonna to discuss to communicate today. And fifth is about six is regarding about some over temperature. So if some poor quality equipment when doing the cable connection, it will be the connectivity will be not so properly. So it will be have some arc, and then the temperature will be increased. It also will be have some damage about the inverter. And seventh is regarding about reverse polarities. So, but now because the PV panel we are using always the female and the male terminal. So currently this type of the faults normally will not happen. And the last one is regarding about inverter internal short circuit. So, but this one is caused by the equipment. So this one, if this kind of thing coming, of course, as a supplier, we will be give some warranty to replace this kind of thing. So for different type of the DC faults, or different supplier have the solution. So no matter it's Sungrow or Huawei, both of us have some solution or protection for to overcome this kind of thing. So for the AFCI, we also have the similar technology. And small adding knowledge is why the DCR is more important than the AC arc. Actually, the arc will be happen no matter at the DC side or AC side. Because the AC current will be automatically reduced to zero. So normally it will be automatic eliminates, but the DC arc will be not. So for the DC side, protection will be more important for us. And these are some normal reasons for cause the DC arc. Some unreliable well PV junction box. So this one will be happen as maybe central inverter or something, and some incompatible connector or unreliable connection, and the damaged DC cable due to the agent. And these are some AFCI technology, just a brief introduction. So in the future, some of the country, they just require to have the AFCI, but no require to build in FCI or external FCI. So some of the product, it has the external AFCI function, but both of us have the AFCI function with the built-in inverter. So the inverter with the built-in AFCI function. So I think the built-in AFCI function will be more common in this market. Otherwise, if you put the external AFCI, the maintenance and the cost, actually it is a question for the engineering work. And this part is regarding about some challenge for the arc detection. The Mr. and RMV also introduced. One is about the noise, because due to the distance increase, due to the current increase, due to the distance increase, actually you will be very hard to analyze to which kind of the signal is the noise, which kind of the signal is really the arc. So all the technology, actually the key requirement is how to identify the arc signal and the normal signal. So these are some standard for the AFCI function. One is the IEC 63027. This one will be more global use for this PV. This standard, the requirement is the voltage up to 1,400 volt DC. And another one is for this one is required the disconnection time, the identification time within 2.5 seconds, and the power requirement, energy requirement. And another one is China standard GBT 39750. So actually this one is referring the IEC standard to give some suggestion. There have the minimum requirement is if your system more than 800 volt DC voltage more than 880 volt, then you should have this kind of the, and then you should be follow this kind of the standard. And another one for the United States is UL 1699B. So this one have the very similar one. Also is within 2.5 seconds, and the arc of 300 volt or higher should be interrupt arc within 2.5 seconds. But as we know, the standard is just the basic requirement of this technology. So if we want to have more advanced, then we better to have a different level of the technology. So one of the standard I want to share is the CGC GF 175 2020. So this standard based on the different power level. For example, if your system is within 100 kilowatt, between 100 kilowatt to 200 kilowatt, or more than 200 kilowatt, based on the different power level, it will be have a different detection requirement, and also have a different arc disconnected requirement. So this is one of the standard. If in the future you're gonna to verify the AFCI is belong to the premium version, standard version, or the basic version, this is a good example for the people to check. And for the AFCI, I think that one important thing is you cannot just base on the paper to analyze this one is qualified or not. And actually, we already also have some. We also do some donation for with the SEA. So there is one FCI laboratory. So if have chance, we are very welcome you to coordinate with the CEA to see which kind of the brand is really have the AFCI, which kind of brand is really is not have AFCI. Actually, all the thing we're gonna do is want to protect your own assessment and protect this industry to make this industry more sustainable to development. So for the inverter side, I will not talking too much about that. So next part, I will be moved to the energy storage system. So for the energy storage system, the DC side, actually the DC side will be not very simple like the inverter. So inverter DC side is very easy. Always say PV solar system, PV system. DC side is very easy. The PV panel, the cable, junction box, if have an optimizer and the supporter, this kind of a thing. But if we looking for the battery, then the battery will be different because the whole container actually is belong to the DC side. So the whole container including a lot of the component, the battery cells, the fire extinguisher system, and the battery management system, the cooling control system. Actually, all this kind of thing is belong to the DC side. So currently, because past 5 years, the battery industry have a very rapidly increasing market. But because in the very early stage, the standard is not so mature and the operation is not so mature, installation is not so mature, actually have a lot of the accident. So how to control this kind of the accident, how to eliminate this kind of the accident, how to control from the DC side is very important. So actually, for the DC side, the mainly equipment is the battery. So actually, a lot of the accident before it happened, it will be have a lot of the indicator. So as we all know, for the lithium battery, normally will be cooperate the battery management system. So the very important thing is how can we using the battery management system to monitor all the parameter and give us the pre-alarm. So let's see, even for the cells, what kind of data we can monitor, like the cells voltage and the cells temperature. So if the cells voltage is more than the normal voltage, it means that it have the potential to have the overcharge. If the cell's temperature is more than the normal temperature, then it also have the potential to have some thermal runaway. And also for the pack, similar thing, battery pack voltage and battery pack temperature, and this kind of the thing should be monitored by the BMS system. And from the pack level, we can come to the container level. So also some similar parameter we can monitor temperature, whether the cooling system is running properly, whether the compressor is full, or even some leakage of the liquid coolant. This kind of thing we also need to monitor. But monitor is not our result, is not our purpose. Our purpose is using this kind of the data to give some alarm, to do some analyze, to help the people to understand about what is going to be happen after maybe 1 or 2 months, or even half years. So after we got this kind of the data, we will be based on the algorithm to using the big data to analyze, because we have already have a lot of the global project. So it means that we have enough data to do this kind of training, and we also have the laboratory. So we can base on the laboratory data to do some synchronize. And then we can understand what is the safety hazards. It will be happen. We can be analyzed in advance. And we also can identify the issue at both ends in advance to avoid the passive fault shutdown. And the last thing is we can provide some operation and maintenance suggestion to improve the operation and maintenance efficiency. Just assume like if one of the battery you have the potential to damage or the efficiency is reduced, the battery management system can give you the pre-alarm. Maybe this battery pack is having some abnormal degradation. Then we can prepare the hardware in advance and no need waiting something really happen. Then you're doing the replacement. Then it will be lose the generation and it will be lose the availability also. So this is for helping to reducing the OMM costs. So you can see, through our full link data collection, I mean, it's not just for our solution. I believe all the battery supplier or the solution supplier, it should have this kind of the system to collect the information like the cell information, like the cell current monitor, temperature monitor, storage deviation, and the SOH deviation analysis from the cells, pack, rack, to the liquid thermal monitor system, and then for the whole container. And definitely PCS and the array and the whole power plant also need to be monitored, but that is belong to the AC side. We're only talking about the DC side. So after collect this kind of the data, this system, this solution should be have the long period to continuously to doing the analyze. And our final solution is make the whole system more high availability and have more active safety and assist to do the operation and monitor and maintenance. So this one just using our product and our solution as an example. So our system actually the principle is we are deploying the computer power server in the power monitor management system and loading all the feature license, and then we can activate our smart health guide feature. So to make sure our full link data is collection to aggregate to the SPMS server and to doing the real time to do the calculation, run the algorithm mode, and then conduct the evaluation and warning. And finally, to a presentation of the warning information, providing the diagnosis, analyze the report. So this is the normal process of the battery management system to secure the battery, to secure the whole power plant safety and more efficiency. And so this one just one diagnosis report for you to example. It will be showing some impact analysis, root cause identification, and operation maintenance suggestion. And it will be showing the original data curve for you to reference, for you to understand what's going to be, what's already happening in this system. And then everyone can understand this industry and this product. This is something about our product. I don't want to go so much deeper in this. And I will go to the next one. Is regarding about the designing of the fire protection system for the energy storage. So actually, the energy storage is a comprehensive product. So it will be including a lot of the thing, the electrical engineering, ceremony management engineering, and the chemical engineering, and even the grid stability study. So all of this, it will be affect the safety. But mainly for the DC side, there are three parts when we're doing the design of the project, of the equipment. So there are mainly three parts.
We cannot hear you.
Yeah, hello? Wait, let me see. Now cannot hear? Hello? Can you hear now? Hello? Hello, sorry. Can I know which part you cannot hear me? Okay, could you see my screen now? Okay, sorry. So I will continue for this part. The third part is regarding about the design of the fire protection system for energy storage. So actually, for the ESS energy storage system is a comprehensive product, including the electrical engineering and thermal management engineering and chemical engineering and grid stability analysis studies. So, but for the DC side, when we're doing the design of the whole battery container, what kind of the factor we need to consider? What is our design, the ideologic? So actually, all the container design, even including the AC side design, these are three main parts to consider. One is about machine abuse or the mechanical abuse, how to control the mechanical machine abuse, electricity abuse, and thermal abuse. So all these designing factor is to control these three abuse. So from the designing stage, testing stage, testing stage, incoming material, process, transportation, and storage, delivery, and operation and maintenance. You can see during all this stage, we need to consider about how to control the machine abuse, electrical abuse, and thermal abuse. So actually for the battery pack, actually is how to make sure if something really happen, how to control the thermal abuse. For if the battery cabinets really have fire, so how to eliminate the hazard for the people, the environment. So this is the purpose of the fire extinguisher system design. So you can see these are the this is using our product, our solution as an example. So you can see from our solution, there we say have three layers for the fireproof, and 3 layers for the explosion proof, and 2 layers for the anti-diffusion. So what's the meaning of the 3 layers fireproof? So for the cells level, the cells is inherent the safety. So the cells, when we have the income material, we have the high requirement for the cells. And when we're doing the installation between the cells and cells, it has some silicon foam. It can be protect if the cells really have the burning, it will be no split, it will be no separate to the other cells. Another one is the pack level. One is in heat spread suppression. Another one is active pressure relief. So what is the meaning of the active pressure relief? So as we all know, when the battery is some chemical device, if have some thermal runaway, it will be have a lot of the hydrogen and the other type of the gas, which is very easy to burn. So when the thermal is really happen, the battery pack have some one direction volt to make sure this kind of the gas can be relieved from one direction. And then because of this kind of volt, if some arc is happening during inside of the cabinets, inside of the container, because the gas is not there, and then it will be not cause the fire. So this is for the pack level anti-hard spread. And then another third level is the container level fire suppression. So this one will be more easy. We are putting the cylinder inside of the cabinet. So if we detect no matter is the gas or the temperature is higher than some certain value, then the gas will be not automatically relieved. And the third level to explosion proof. One is about the pack level direction smoke exhaust. This is what I say. We can have the direction smoke exhaust to make sure the gas will be not remaining at the container. And the second one is the container level active exhaust, electric lower plus explosion proof fans. So at the back of the container, it has one train for the gas. So after the pack relieve the gas, it will be through the train to release outside of the container. Also to prevent the gas remain at the container. And the two layers to anti-diffusion. So container level fireproof and the heat insulation fire diffusion surface is more than 2 hours fireproof. So even after this one, why have this kind of requirement? Just imagine after burning, maybe 4 hours, 6 hours, 8 hours, even 10 hours. If you want to move this container, I definitely cannot be used. If you want to move this container to somewhere, then your system should be stable to using the crane, even forklift or crane to move this one to move out. Otherwise, if someone to doing the moving work, then it will be caused the second time hazard. So this is our fire extinguisher system. So what we are design and what we are consider. So I think maybe for Sri Lanka, I think today all the guy come here, it should be the engineering. So when we checking the system, when we're doing the design of the system, maybe we can consider more about this. So these are some principle to introduce about how we do the active exhaust. So we can see that there is active exhaust fans. If something relief, we can through these fans to make all the thing out. And another one is the fire sprinkle system. So because in some region, if you want to make this fire to eliminate as soon as possible, you also can connect the water to using the water to doing the sprinkle, water sprinkle to make the whole system become cooling as soon as possible. And these are some explosion ventil solutions. So these are to prevent if someone is doing the maintenance work and then the explosions happen, to avoid this kind of thing to damage the people. There is a small video I want to show. So even the people just 2 meters away from the door, the people will be no damage. And for the top mount explosion ventil solution also there, this one will be more easy to see. If you are using the top mount, if someone in front of the door, then you will be not damage the people. And these are some fire resistant rating of 2 hours. So after large scale fire resistant test, our container cover is still can remain stable. And then maybe the fire accident is really coming, then we can move it out and maybe install the new one. Okay, so actually these are some introduction about my my topic. So thank you for your all. If you have question, maybe the next topic, you can ask me. We also hope to have actually a lot of things we still not discussed. So we hope we have opportunity to have more deep discussion. Thank you.
Thank you, Engineer Mo. We have come to the last presentation of this evening. With over 14 years of professional experience in the power sector, our final speaker of the day has been actively engaged in the operation, maintenance, and management of hydro and thermal power plants, as well as power distribution systems. He currently serves as the Chief Engineer of the Ratmalana distribution area and has held multiple engineering and project management roles across major generation and grid projects. He holds a BSc Hons in Engineering and MSc in Energy and postgraduate qualification in Energy and Law, bringing strong multidisciplinary expertise to the field. He is a chartered electrical engineer of the Institution of Engineers Sri Lanka and an international professional engineer, reflecting his strong professional standing both locally and internationally. He has also contributed significantly as a senior electrical engineer and energy consultant within the Sri Lanka Sustainable Energy Authority, playing an active role in advancing energy systems and sustainable development initiatives in the country. Please join me in welcoming Engineer Charit Shanakar to this stage.
Good evening to you all. Thank you for inviting me, IESL, and the committee, sectoral committee, for inviting me for this presentation as the technical forum. And thank you very much for nice presentations from Engineer Amila and the engineers from Sangro and the Huawei. So as the utility services provider, so during these other presentations, I come across many of solutions for many of problems at the moment I'm experiencing, and I would explain a little bit more about the what's going on in distribution areas, and what are the future requirements, and what would be the future commercial model as far as the distribution energy business is concerned. Yeah. Yeah, if you take Ratmalana power distribution area, I have about 111,000 customers. There are 3 consumer services centers called Ratmalana, Borlasgamua, and Kasbaba. And I have already installed 65 megawatt plus 65 megawatt renewable energy rooftop solar at the moment, including bulk customers and ordinary customers. And altogether, we have prosumers, about 5,200 prosumers, because I call them prosumers because so Engineer Amila will be agree with me, because we have customers, electrical customers, and they have become producers as well. That's why we call prosumers. So in the future, we have to look forward, look after them as prosumer safety, and to support prosumers, as well as we have to implement guidelines and some instructions for prosumer ethics. When we talk about DC safety, the today's topic, all of our talented presenters explain about the safety concerns and the problems experiencing. So I will, during these presentations from the Huawei, the sponsors, we learned that lots of problems have been addressed by the manufacturers. So what I experience is, at the moment, our senior engineers would agree with me, because that even though these technical aspects, technical developments are integrated with system, these inverters and all systems, the protection schemes, and everything. But when it comes to the market and the prices of the product, most of features when we import these products, most of features is blocked or they won't take. They don't take. So that's why most of the time we are experiencing lots of difficulties during the installations and this prosumer safety matters. Yeah. So as an area engineer, I have noticed a lot of structural issues beyond the normal rooftop area. So I will show you some pictures I have taken. In some of areas, mostly there's remote areas like some remote areas and high DC voltage installation at voltage isolation at poles and extra PV arrays. Adding more, the engineer, our PUCSL engineer, Mr. Engineer Amila explained about the adding extra PV panels, and prosumers produce more than the approved capacities. Though then we experience some other problems. I will explain a little bit more about in my other slides. This is one of you can see something like nice house, but you can see the installation is about 40 kilowatt system. This was installed, I think, I guess in 2023 somewhere in far remote area. So this kind of practices are there because of renewable energy tariffs and the investment opportunities raised by the previous initiatives. So we have guidelines that we allow only for effective roof areas, but sometimes we would experience these things, and we have removed these panels, and we have instructed our prosumers to remove these installations and be aligned with the guidelines we provided, CB or EDL provided. And this is kind of other installation. We could see that panels have been already bended because of these rails. I think there are some today also presenting some solar companies who engaging with installations actively in the industry. So most of the time these kind of some of cases like this, and you could see these spaces spaces between rails are very high. So then the panels going to be bent with the time, and the stability and structures are not suitable for long-term running of these solar systems. And this is also kind of insulation issues. This may cause a lot of insulation issues, even fire issues. So these insulations are made by PVC and some no-leak tapes. So this kind of installations we have seen some places. I'm not talking about all. Some installations are there like that because prosumers are not properly safe, and their safety has to be assured, because they are making a lot of big investments, going for big loans. So I would say that I have 65 megawatt at the moment, so I haven't spent any rupee for this installation. So that's what that advantage is there. This is also just an electrical isolator. It's not a overcurrent protector. And you would see some other installation. There are PVC pipes not up to the standard. We have PUCSL and CB imposed. This is how our engineer Amila explained that the growth of renewable energy within 2.5 years or 3 years time, there were added 2002 gigawatt rooftop solar installation into the national grid. So because of these installations, we could see, as far as the safety matters is concerned, we could see protection blinding, that bidirectional flows of current. Some protective devices can't measure actual fault currents because of those bidirectional current flows. It's there. So a lot of developments, maybe our engineer would think of those things and implement new models for these protection requirements. And reverse power flows. And because of the reverse power flows, our transformers experiencing other pumping power to other the high voltage sites, but which the distribution transformers are not designed. So degradation of high rate of degradation would be there in distribution transformers. So then I will little bit talk about the BESS. BESS are not in properly this battery energy storage system concept. That requirement is there. I would explain in my next slide how much of battery energy storage is important for us, for especially for Ratmalana area. So we see our presenters were talking about, and our engineer Amila also explained about the battery requirement and the safety requirements of battery storages, because it's going to be really tough and properly look after batteries, because there's a huge fire risk of batteries, because always they're getting exposed into high heat. So yeah. Now, if you talk about the current situation which I am experiencing in Ratmalana, so because of these renewable energy developments, there were 18 megawatt into 2024, about in January 2024. Now we have 65 megawatt of renewable energy added to the distribution network of Ratmalana area. So you would see in December 2021, so that DG loss means distribution generation loss due to network limitations. You can take up before means into 2025 it was 21%. It means the targeted generation out of the installation, we lost 25% of energy because of network limitations. Now you could see in the 3 months of time, so we still provide 5 kilowatt solar systems based on the customer requirements and the electricity tariff changes. So it has become 28% now, but the targeted generation loss about 28%. If we add more renewable energy to the distribution network without storages, this thing going to be over and over, and it's going to be useless investment. So we have to look for safety battery energy storages and their safety, and prosumers more and more, because they are to invest. Even though I feel that I got 65 megawatt at the moment without spending any rupee. So for batteries also, if we have implemented proper systems based on our regulations and all, we would be able to get that installation as well without much effort by the utility service provider. And distribution energy tariff, you could see. So I buy at 30.1. It means 30 rupees and 10 cents. One solar unit I buy from our prosumers at 30.1. When we take the Hivala area, so it was 28.8. This is my personal studies, and for the general type is about 42 to 45. So we can keep that markup about 12 rupees if we add more renewable energy into the distribution network. So prosumer cares, I have added these insights also, providing solar clearance in short study. for prosumer, considering the prosumer's requirement. So that's why we miss a lot of technical considerations of these installations and prosumers capacities because of this trends. The last 2.5 years, there was a huge motivation to get electricity, renewable energy as an investment purposes. So because of that workload, that load of applications, that demand, we have to we miss mostly look after these customers because of inspecting the sites and inspecting the systems is not so so easy task, because it's really tough work because of the load of applications. Anyway, so chartered engineers are inspect these systems mostly, but sometimes I don't know sometimes what is going on, but there should be proper regulations, as our engineer Amila explained about these things, because there are some other additional panels which which is beyond our controls. Most of the time we see some breakers are burnt out and meters burn, and when we analyze, their generation is more than expected because they have added panels. So we have to disconnect those customers. Sometimes they come for us and they begin these things because of they have go for a lot of loans and like that. So because of that, so we have to regulate those things when it comes to the business from the beginning. So that's what I'm personally I feel as an area engineer. And then the pilot study using open. So once we experience these limiting renewable energy generation, so we did engineer Navodhan also helped me for that open DSS platform. We study our network using open DSS software. So we analyze a lot of feeder augmentations, parallel feeders and transformer augmentations would be helping these. It would help to get these generation as much as possible into the national grid, to the distribution area networks. Then we keep the national grid as energy reserve. And network augmentation proposals also we have raised to our planning and development branches, because as far as the transformer density is concerned, Ratmalana area is little bit less, but comparatively renewable energy development is high. When it comes to actions and studies, DG penetration distribution, modeling rooftop solar systems in open DSS systems, and I added another thing here for implementation DSO. It means distribution system operator like NSO, because we can, at the moment I have two systems online. I can monitor. I have make that facility in my my area office. So we have to monitor these inverters and control the penetration based on our requirements. So the customers, the prosumers has to be aware about the requirements, and we all together with the utility service providers, Sustainable Energy Authority and the PUCSL, we all have to educate prosumers the requirement of the controlling energy penetration to have a stable system. And so for solar trading, we can have blockchains. So that kind of initiatives can be see in the future. So this is when it comes. Since I am going to conclude my presentation, so I added this concept where the future distribution area would be, because we have safety concerns. We have to think of prosumers, and we have to think of tariff reduction, and we have to think of small customers, and we have to think of big customers like industrial developers, industries, because we have to support industries as much as possible. So as an area engineer, I'm not in a position to ask my customers to reduce your consumption. So I want to force them to use as much as possible, because I have energy there, the grid is there, so we can sell our energy to them, and they can use their energy, they can have a comfortable life. Then we can generate. So energy is there, technology is there, so we can consider. So that's why I added that ecological modernization and circular economic principles to be embedded to the future distribution area models. It means it has to be a business model, either business model or commercial model. And these policy regulations, the other compliance also assured with the national policies, as our engineer explained about the future regulations. And these matters were properly discussed with our sponsoring engineers about the future, how to detect faults and what are the standards. And it's really comfortable and it's really relaxing thing, because we have that safety and we have that technologies. Then we have to implement those technologies without considering the budgets and all. So we can achieve that gap somehow with promoting safety standards. And these things also talk about we talk, and I will little bit go through about the utility actions as far as the proper policy and regulatory frameworks is concerned. Smart meters, we should have smart meters, and we can directly communicate with our customers, not only prosumers and customers, and feeder level protections. So we have already implemented some protections that enhance that distribution medium voltage levels, but for low voltage levels, we have as investments, we have to consider those things. And drone based aerial inspections for high density solar, that thermal imaging like that. So we have to implement, and DSOs, being a DSO, and emergency response protocols for fire hazards and all. And key message from distribution action: safety cannot lag behind growth. Sri Lanka has 2000 megawatt of rooftop solar in recorded time. So we have that energy, and we have to add the infrastructures as early as possible to harness that energy. As I explained, 28% of energy I lose, and other areas also we can calculate based on the available data and the other standards implications. We have institutes, we have regulators, we have good engineers in us, and IESL. We can do a lot of things on behalf of prosumers and customers. And I'm going to wind up the presentation because of the time constraint. Thank you very much for inviting me, and have a pleasant evening. Thank you.
Thank you, Engineer Charit. This brings us to the conclusion of the presentations of this evening. We would like to extend our sincere appreciation to all the speakers for their valuable insights and contributions in this evening. We now open the floor to our audience for the Q&A session. I would like to invite Engineer Savin to take the stage to guide the discussion.
Good evening, everyone. Welcome to the panel discussion section of today's technical forum. Here we have approximately 20 minutes allocated for this discussion. First, I will direct a few questions to our experts. Following that, we will open the floor for floor for questions from the audience. So without further ado, let's begin the discussion. I would like to direct the first question to Mr. Amila C. Rajapaksha, Director of Environmental Efficiency and Renewable Energy, PUCSL. My question is, lithium ion phosphate batteries are becoming the standard, but they are difficult to recycle. So what should be the plan for safely disposing of these batteries in Sri Lanka in next 10 to 15 years?
Yes, your point is really valid point. Now, in my presentation, I really explained as per the existing Sri Lankan law, Central Environment Authority has the mandate regarding this what disposal of the batteries and all. So really, we had a discussion with them because not only the batteries, solar panels as well. Now, in years to come, there would be a lot of solar panels as well as the batteries to be disposed. So there should be a mechanism we need to ready with the time for this disposal and all. So actually, right now, what the existing legislation said, for disposal and all, there should be a licensed party. The licensed party should collect whatever the items or batteries or solar panels, and they have to dispose as per the whatever the existing methodologies and existing standards. But right now, at the moment, there's some market aspect as well, because for a person, for a licensed person means again a company, an organization to make a kind of a disposal business, there should be a viable business. There should be a demand for as well. So that economics have to be considered as well. So right now, at the moment, as my understanding, there's a company in the BOI zone in Patnaika, but still they are struggling. They don't have a necessary demand for their business. So definitely, yes, there should be a procedures and regulations for the disposal and all. I would like to share this. We should take other countries. There's a concept called battery passport. That means if you got storages, there should be a kind of identification. Sometimes the agent or the importer are responsible for the disposal as well. So that kind of mechanism is in progress right at the moment under Sustainable Energy Development Authority. They are going to amend their what you call Environment Act. So then it's a bring the kind of a passport kind of mechanism, not only for the batteries, plastic, and some other as well, where it had a kind of identification, it has a kind of a data, and ultimately importer or some third party person is responsible for the disposal. So we can see when we import in batteries or plastic or whatever the items, there's a kind of a database we have, how much we imported, and end of the day, this amount of it import and this amount of be disposed. So data is there, and we need to go with that kind of a regulation for batteries and all, as to my understanding.
Thank you, sir. Now I would like to direct the next question to Mr. Charit Chanaka, Chief Engineer in Ratmalana area, EDL Private Limited. Question is, with the rapid growth and popularity of off-grid systems, what measures are being taken to monitor this installation and ensure that public safety standards are being met?
As in my presentation, I explains the requirement of the energy storages because of that. So then we can save that energy because because of the inverter tripping, we lose that energy, and then it causes the since the grid limitations. Because of the grid limitations, we lost our energy, and inverter get tripped. So then we can have storages. That's the concept. So normally, because of these network limitations, prosumers are go for the battery storages. Then as far as the standards is concerned, as I explained it, there are a lot of substandard. Our engineer explained in this in Australian case his presentation. So substandard batteries are there. So we are there to, as in engineers, as expressed, we have that responsibility to educate customers, and accredited companies has to rather compromise in their profits or something, their margins. They get that good batteries, standard batteries, and the safety packages given embedded in the inverters and the battery management systems. Those facilities are there, those technical things, technical measures, nice technical developments we saw during their presentations, our sponsors. So we could see how tough, how intelligently they solve these detection of faults and the management of these technical issues. So we have to get those technologies to our countries, and we use those things without thinking of the profit margins and etc. So they are there, they have developed standards is there. So we are there to implement and educate our customers and the prosumers, but we have to get those technologies without eliminating for the profits.
To add what Mr. Charit said, as added information, now if you take a distribution licensee, if they have a grid connected system, yes, distribution licensee has a direct contract with them, agreement with them. In violation, in understand it, implementing, definitely just through the agreement, they can go for whatever the disconnection node. But when it comes to the off-grids, there's a no agreement between the distribution licensee and the customer or the prosumer. So how the distribution licensee can see or inspect them, because that is beyond their binding, the control, beyond the meter. So that issue is there. That's why in my presentation I pointed out there should be a responsible person in Sri Lanka for any electrical installation or the modification. That's the practice in other countries. Without a license or an accredited electrician, nobody can do the wiring. If you see some other countries, that's the practice. But in our case, there is a difference. So we have to think about in an era where any installation, domestic or non-domestic, any installation, whether it's a grid or off-grid, and any modification of the same should be done by the accredited electrician, and he should be responsible for person for this installation. So in such case, if whether it's a grid or off-grid, that person is responsible to install the standard product, standard wiring, and no. So I think that should be the future of our country.
Thank you, sir, for the valuable answers. Next, I would like to direct the next question to Mr. Aaron Lee, Solution Manager of Sungrow. My question is it safer to install home batteries indoors or outdoors? I mean, whether there is better ventilation. And what are the minimum fire safety requirements for an indoor installation?
Okay, simply repeat about your question. I didn't get that.
Sorry. Okay. My question is it safer to install home batteries indoor or outdoors? I mean, where there is better ventilation. And what are the minimum fire safety requirements? Fire safety requirements for an indoor installation.
So as for the DC side risks, as for the rooftop, I do think there are different technology and different brand, and every brand has its own pros and cons. But the problem here is that we don't have a mandatory regulation for those brands. So every brand says they do have their advantages. But as I said, as an engineering, my attention is more focused on the technical details. So like Thailand, like America, they that have their own mandatory regulations. So yeah, it's I think it's a necessary conditions for some brand to entering the Sri Lanka's market. So that's supposed to be the precondition. And on another hand, for the technology side, there was no such a limitation how many we can deploy on the rooftop, no such kind of thing. Okay, that's from my side.
Thank you, sir. For my next question, I would like to invite Mr. Mohaiki, Senior Solution Manager Huawei, who is joining us in online.
Please.
My question is, metal cable trays provide better UV protection than PVC or DC cable laying, but they increase the risk of dangerous DC earth faults. Does the panel Does the panel prefer metal or PVC long-term safety? And how should we manage the grounding risk of metal trays?
Sorry, could you repeat again?
My question is, metal cable trays provide better UV protection than PVC or DC cable laying, but they increase the risk of dangerous DC earth faults. Does the panel prefer metal or PVC for long-term safety? And how should we manage the grounding risks of metal trays?
Yeah, actually, I think this is regarding about some engineering question. So this kind of the ground fault, based on our experience, most of the ground fault actually is happening during the installation. So during the installation, maybe because we know in the real installation scenario, maybe some distance is not enough for us to do the placing of the cable. So in some bending area, definitely it will be touching some metal plates or this kind of place. So first, for the grounding issue, maybe 70% is during the installation. So very easy, very important thing to eliminate this kind of the grounding issue is we need to make sure when we're doing the installation should have a good quality. So how to identify the quality? Actually, I think all of the supplier, they have the requirement for the bending angle and the requirements of distance. So this kind of a requirement better to following. So these are the first thing when we're doing the installation. And second thing is consider about the future operation and maintenance. So as we all know, some area is in some rural area, some insects, some pets, some wild animals, all this kind of thing might be cause the damage of the cable and then cause the grounding issue. So if some of this area is in some rural area, then we should have a more protection mechanism to protect this cable. Like we can using some covers to something to cover all the cable, or using some mesh to protect for the big animal. So these are something I'm thinking if we want to reduce the grounding issue during the installation of the PV.
Thank you, sir. At this point, we would like to invite questions from the audience. Please feel free to ask questions.
Hello, can you hear? Anyway, thank you very much for the presenters. This now today, all of you discussed about this safety, especially coming from the inverter side, all internal. But what about sudden lighting? An EMP strike could easily cause a massive spark in the solar array, and that could generate, due to weakness in the insulation, a massive fire. So what could people do, or what could be the safety features which could be incorporated into such systems? I mean, like, of course, this is not a direct strike. I'm talking not of a direct strike. A strike adjacent to the installation can create also theoretically a spark. Now, if it is the safety of the people, especially a rooftop, it can ignite a fire in the building.
You mean something like transformer protection, water protection, or something, lane hydro protection, something like detecting the heat and trigger it and spraying some water and
No.
extinguish the fire.
An EMP, like lightning strike in an adjacent building can create an induced current in the solar array, no? Because there are a lot of DC loops, in this whole system. A massive strike can ignite theoretically, but that is a safety concern, isn't it?
You are talking about worst case scenario.
Yeah. But then it can happen because it's an act of God. I mean, so my question is, can the inverters be fitted with some kind of, protection to immediately cut it off, or is it available already? Or maybe an SPD, like SPDs can be, incorporated into the system at least to protect direct strikes. Is it possible? I mean, talking about safety, Thank you.
It's basically you are asking a kind of a direct strike, maybe nearby direct strike that may induce a sudden, yes. But what I feel when we're designing our any installation, we are in line with the BS standards and what is the protection mechanism we have to incorporate. But what I feel as per the existing standards and the existing designing procedures, they have a kind of a protection equipment we are incorporating, including SPDs and all. So I believe, as per my understanding, I'm not much know about the too much technical about that area, but what I feel the existing technical arrangement and protection system are enough to handle this. But I know if it's a larger spike, I know it may not be the protection system may not be adequate enough to handle the case. But in that case, I believe I think our experts from the Huawei and others, they may have some possible solution if there any sudden strike, sudden spike. Yeah, inverters have any kind of a solution to disconnect the system. I saw there are some that in Arcanol, we have some protection mechanism to disconnect. But the similar protection mechanism do you have? I saw there are so many protection Senashu explained. So just the gentleman is asking, sudden strike or spike happen. Is there any protection mechanism inside the inverter to disconnect the system or no? Just if you have any idea.
For the high voltage, actually, as I mentioned in the slides, we do have the rapid shutdown. Actually, right now in Sri Lanka, it's an option. But in other countries like Thailand, yeah, it's necessary to equip the PV system with the rapid shutdown. So when there was a emergency situations occurs like the fire, so you can use the emergency button to stop the high voltage within 20 seconds. So that's how it works. And as for other like the poor installation, I'm saying the connector creeping, right? So yeah, there's another reference from South Korea. They put a fuse on the connector. So even if you cannot guarantee every connection point is installed correctly, so the fuse will take the responsibility as the last step to stop the fire. So that's what I'm understanding.
Sorry, sir. Let me understand the question. This gentleman is asking about when the lighting is happening. What kind of protection is there, right? For my understanding, is asking about if the lighting is coming. Could you repeat your question?
Sorry.
Yeah, for my understanding, this gentleman is asking about if some lighting.
Are there any questions from?
Yeah, I'm speaking. I want to answering this question, so I want to understand about this question first. Whether he is asking about if some.
My question is not about a direct strike or the installation itself, but an adjacent spike can induce, we call it EMP, can create, because there are a lot of DC circuits from the solar panels to the inverters, and it can create theoretically a spark and then ignite the system. So do you have any protection for such, like remote, but still it can happen theoretically? So is there any system that is there fixed into the like inverters or the panels which can prevent such disasters? Thank you.
So you mean when the breaker is switching on and off, that spike, right?
No, even on your systems, like at least to prevent and disconnect the system.
So
Because I saw
actually,
that in some of the videos that the fire was fire didn't spread onto the other areas. I saw in one of the videos that there was a fire. It was tested. The system, the
okay.
tunneling system, tunnels were tested, and the fire didn't spread onto the adjacent areas. There is a system to curtail that.
So let me try to answer your question. Okay. So for example, like Huawei inverter. So actually at the bottom of the inverter, there is one manual switch. So that manual switch will be detect, for example, if some spark happen, then the temperature definitely will be going up or the current will be going up. So the switch, the DC switch will be automatically switch off. So this adds some emergency stage. So if some emergency happen, for example, like what you say, spark or overcurrent or over temperature, the switch, DC switch will be automatically switch off. So this is an emergency situation. And when we're talking about normal situation, if we see all the process for power on or power off the inverter, actually we have some very mature process. We need to be power off from the system first. Why? Because inside of our inverter, actually they already have a lot of the relay. So if we can switch off the relay internally, then when we're doing the installation or doing the maintenance work, actually it will not have too much risk to when you're doing the connection or when you're doing the switch on and off. So this is from the inverter side. And another side is from the PV panel side. So like Arandi also mentioned, like the ISD equipment or the optimizer equipment. This kind of the equipment, it can be isolates the DC voltage. So if you isolate this kind of the DC voltage, if the PV panel is still generating the power, but the voltage is not there, then also will be no current. So when you're doing the installation or operation, this kind of the spark also will be, it will be prevent this kind of the spark. I don't know whether my answer is can be answering your question.
Okay, thank you, sir, for the valuable answer. And as we are approaching the end of the allocated time for this session, we will conclude the panel discussion at this point. And I would sincerely thank you all for your valuable insights and expertise with sharing us. And it has also been a privilege for me to be part of this discussion. And thank you for the audience for valuable questions. Thank you.
Thank you to all our speakers and participants for that engaging and insightful discussion. With that, I would like to request our panelists to take their seats in the audience.